This tutorial is going to show you how to solve quadratic word problems that involve profit. Now, we know that when a company makes a product and they sell it, the money coming into the company is called the revenue. There are costs associated with making the certain product that they're selling, and those are the costs. And then the profit is the difference. So the profit is the revenue subtract the cost. Okay, so in this word problem, they're describing an orchard, and the orchard currently has 100 trees planted, and they know that their analysis of this orchard has told them that the annual revenue per tree is $90. So they aren't happy with that, and what they'd like to do is they'd like to increase profits. So what they propose to do is to change the number of trees that are currently planted in the orchard. Now, the problem with this is the more trees they plant, the less room each tree has, and its revenue, or its number of pairs that it generates, goes down, so that the revenue decreases. And analysis has shown that every tree that is added to the orchard results in the other trees' production being reduced by 70 cents. Okay, so there's the revenue. They're describing how the orchard makes money or gets money coming in. Now, obviously with any orchard there is costs associated with running the orchard, and they have analyzed that, and they tell you it is $7.40 per year per tree. Okay. The final sort of little bit of information that they're asking for is how many pear trees should be planted to maximize the profit. All right, so we know that we are dealing with the profit equation, and that is the one they're interested in, the maximum, the optimal value of, and that word should imply to you vertex. You need to get the vertex. All right, well, let's go ahead and get started, and we'll show you how to start and work with these word problems. The first thing we're going to do is we're going to create a variable that is going to help us out, and I'm just going to say let x represent the number of extra trees planted. So x is going to represent sort of the increase, the change from the status quo. All right, knowing that, I can now write a couple of equations. Okay, so the first equation I'm going to write is going to be the revenue equation, and it is going to be based on x, that is, the number of extra trees. So if we change the value of x, if we add more trees, we're going to change the revenue. It should go up as well. All right, when you're writing the revenue equation, first thing I want you to do is I want you to write the way things currently are. And we know that to generate revenue, I just need to know how many trees are planted. So the number of trees, and we can just give ourselves a little reminder here on the side. Revenue is number of trees times, well, the amount generated, or the revenue from each tree. Okay, so I'll just say the revenue per tree. All right, so going back to our equation, we know that currently the orchard has 100 trees planted, and the revenue per tree is $90. Okay, we're thinking of changing that though. We're thinking of increasing the number of trees planted. All right, so that would increase this 100. And if I just add an x on here, then that means that if x is 0, I'm leaving things the way they are with 100 trees. If x is 1, now the revenue has gone up because I have 101 trees. If x is 2, it's 102 trees. However, this $90 revenue does not stay at $90. It is actually reduced, so it goes down by 70 cents for every tree planted. So there's where the x comes into the revenue. Okay? All right, let's take a look at the cost equation. Cost equation, very similar. It's going to depend on the number of trees, and then the cost associated with each tree doesn't vary at all. It just says it's $7.40 for every tree. So here we're going to put the number of trees, and this is the cost associated with those trees. The number of trees, we just copy this equation right from above. It's 100, and then the variable is plus x. Okay. Well, we're ready to move on to the profit equation. The profit equation, we know, is going to be our revenue equation. So that is the orange equation here. And from that, we are going to subtract the cost equation, just like that. So what I'm going to do is I'm going to go ahead and expand this revenue equation, so this binomial times this binomial, and you can do this on your own, and you can check that you get the same answers. But if we expand it out and organize them in order of their degree, we get negative 0.70 x squared plus 20x plus 9,000. If we do the same for the cost equation, we get 7.40x plus 740. Okay, combining these together and removing the brackets so that we get an equation that is just defining the profit. I'm going to remove the brackets, combine like terms. Be careful, we've got minus 740x and minus 740. So it is negative 0.70 x squared plus 1260 x and then plus 8260. And I should feel pretty good about this 8260 value because the revenue for the orchard, if there were no costs involved, is 9,000. But once we account for the cost of maintaining each tree, the revenue or the profit coming in is only $8,260. So there's $9,000 in revenue coming in, but once we account for the cost, you can see our profit is less than 9,000. So that tells us sort of that we're on the right track. Also, we have a negative here in front of the x squared term. This is the a value, and this indicates that we have a parabola that is opening down. Important to have that negative out in front because a parabola that opens downward is going to have a maximum value, and that is going to be what we're looking for because we're asked to maximize the profit. Okay, well, if I could just take this profit equation and if I could just rewrite it into vertex form, well, we'd be away to the races because I could just read the vertex right off. So I'm going to use completing the square to rewrite this in vertex form. And I'll go through the steps fairly quickly. First thing we want to do is we want to factor out this negative 0.70 in front of the x squared term. So negative 0.70, and then I'll put in a couple of brackets here. The 8260 is not part of the perfect square, so it's just going to sit out to the side. And let's just focus on the inside, which is the perfect square. So when I factor negative 0.70 to the first term, x squared is all that remains. Factor that out of the second term, and we get minus 18x. All right, now I need to complete the square now. I need to create a perfect square. To do that, I look at the 18, and I take half of 18. Well, half of 18 is 9, and then I square the 9, and that gives me 81. So I can immediately add 81 and then subtract 81. The net change is 0, so I haven't changed the equation all, but what it has done is created a beautiful perfect square right there in those first three terms. All right, move on to the next line. The profit is equal to negative 0.70 times everything in brackets here, plus 8260 on the end. I'm going to rewrite this perfect square in its nice compact format that we're used to seeing. And what do I put inside? Well, x is the first term. I know that half of 18 was 9, and this sign here is negative. Okay, we still have this negative 81 sitting inside. Our next step is going to be to remove these outer blue brackets and remove that negative 81 from inside the brackets. So to do that, I'm going to multiply this negative 0.70 times this term, and then negative 0.70 times this term. So we are distributing this into the brackets. Profit at x then becomes negative 0.70 times x minus 9 squared, and then negative 0.70 times negative 81 is positive 5670. I'm happy to see a positive here because this means that our previous profit of 8260 is increasing. So the final value, when I actually put all this together and we write it in our final vertex form, is x minus 9 squared, and then plus, combine these two terms together, and we get 8,316 and 70 cents. Okay, so, well, how did that help us out? Where's the final answer? Well, the final answer is when we recognize where the vertex is. The vertex is at 9, and right there, 8,316.70. And what does that mean? Well, that means, remember when we started, we said let x represent the number of extra trees planted. So the x-coordinate of the vertex is 9, and that means there were 9 extra trees planted. So to answer their question to begin with, how many pear trees should be planted to maximize the profit? Well, we need our original 100 plus the extra 9, so the answer is 109. That's how many trees should be planted. Okay, we could ask a lot of other questions. They could have asked us what would be the maximum profit? How much did the profit increase? What was the initial profit the company was earning? All sorts of different questions. Well, let's take a look at this graphically to make sure that we understand what's going on. Okay, so to look at it graphically, let's look at the two equations that we had created in the previous screen. We developed a profit equation, and in standard form it was this, and then once we completed vertex form we realized that we were able to write it as this. Well, what do those two things mean? Well, remember, standard form gives us the y-intercept. So I can clearly see that the y-intercept is 8,260. Vertex form gives us the coordinates of the vertex. The vertex is at 9, the x-coordinate, and 8316.70, the y-coordinate of the vertex. Graphically, here's what this does. So if this was the plot, and this is just a quick little sketch, but if this was the plot of the profit equation, we can see a couple of things happening here. Okay? We can see that the standard form equation gave us the y-intercept. And the y-intercept was 8260. We can also see that on the graph, there's the 8260, and it's right there. It is where we originally started when we had 0 extra trees. So that was the initial profit that the company was making. Now, the company wasn't happy with that amount of profit. What they wanted to do was they wanted to add extra trees and move up this profit line. So as they add extra trees, they move up, and they wanted to find out where on earth is the maximum. What's the best that we can do? Well, there's the best that they can do profit-wise, and there's the number of trees it took. Because when we hit 9, we also hit the maximum of 8316.70. Okay, so graphically, these two equations tell the story. We originally started out with $8,260 in profit, and then we ended up with $8,316.70 in profit, and that's because we were able to move from the y-intercept up to the maximum. If the question had been, all right, you know all that, can you tell me how much the profit increased? Well, now they'd be talking about this amount here. It was at 8260, it increased to 8316.70. Simple subtraction would tell you how much the profit had increased over that time. So if you understand what the question is asking, and you understand what these different forms of the quadratic can give you, you shouldn't have any problem answering these types of questions.